Sustainability was not the first thing in my mind when creating this home. First thing that I thought of was creating a healthy environment for me, my wife, and my children. 3 of my children had severe allergies in the past living spaces that we've inhabited due to forced air systems. Now I'd like to show you exactly how I did it. Downstairs we have 3 systems. Water recycling using gray water systems, 2 solar heating and geothermal cooling as a form of radiant systems, and waste heat recovery as a form of heat exchangers inside vent gases. And I'd like to show you that downstairs. To understand all the aspects of the plumbing field, I had to learn physics, chemistry, and mathematics. Those are the 3 main elements that will allow me to understand how each one of these components work, not only separately, but together in its way. First one being gray water recycling. What is gray water recycling? What we do with this, we capture wastewater from sinks, showers, bathtubs, and laundry, run it through an ancient system, basically sand filtration, which allows me to drain and siphon this water via a gravity-fed system. Not pressure, it has to be gravity. This water that's collected after the filtration process is clean enough and pure enough to use for flushing your toilets and irrigating your lawns. This can be then processed in a further stage of carbon filtration and ultraviolet to be purified enough to where we can rebathe in the system again, thus creating a 90% water filtration system that reuses 90% of our water consumption. This is a sample of the water, the one here being the gray water matter from the showers, laundry, and sinks, and after it passes through the filtration, this is how clear it becomes. And the way we've obtained that is from our separate drain line, from this pipe, it travels this way into a manifold into the top tier. This water is dispersed and captured by using a filter sock, a biological filter sock, capturing hair and particles, larger particles inside the system. Then it travels through into this first tier, which is full of sand, plain old, fine granulated sand on a gravity system. Then from the first tier travels into a second tier of sand. From this portion here, it comes through into our holding tanks, crystal clear. This system is so new that I became one of the 6 installers in Michigan out of 16 today. We need to start a new industry with this technology, and this is how the technology works. From the solar panels mounted on our roof, this is a caption set of the solar panels on our roof. This is a vacuum tube, double lined with solar cells inside there. This is pretty much the same as a thermos, storing heat energy inside the center. From that energy that it stores for long periods of time, then that heat then is transferred to this bulb. 69 degrees. We have those temperatures from an evacuated solar system installed in Michigan. How is that possible? By using physics as our mathematical calculations, we know that this rod placed inside a vacuum tube, which it is, will allow water to boil at lower temperatures. Thus, heat rises to the top bulb, passing over a manifold at the top, where the water then transfers that heat onto the water source that is delivered to the storage tank. Water, and on a day like today, 27 degrees, fully clouded via radiation, is heating my house and giving me 68 to 69 degree temperature hot water for the use of heating and domestic water purposes. This is a balanced, looped system that provides equal temperatures for heating and cooling. the water first goes through my solar tank, capturing as much of that free solar energy. Today we have 69 degrees. When we have clear skies, we normally can capture 110 to 115 degrees. This tankless water heater, the technology of tankless water heater, provides us with a very small margin of error. This allows the water, incoming water temperature, to be calculated internally with this computer strip, and allows us to determine exactly how much gas is needed to raise the water temperature up to our heating needs. The water comes out of the unit at its design temperature, then travels through into this balanced loop manifold, which distributes the heat evenly to each zone. From the zones, the water travels through to the subfloor. I installed these pipes to the underside of the floor, which consists of half-inch PEX heating pipe with a 60% glycol mix. Now on this side of the joists, we can see that I have grouped this distribution network for the zone, which then leads up to my second floor heat distribution system. And cooling. The way we cool this house, we have installed pipes underneath this garage floor that is underground 7.5 feet, and that has given us temperatures of 63 degrees. We use that cooling temperature to cool the house using the exact same pipes, a network of systems to heat the house without using any air conditioning equipment whatsoever. This is heat waste recovery. What it consists of is a heat exchanger inside my vent gas piping. As this unit, which is my domestic hot water system, releases carbon monoxide at 157 degrees minimally, I can capture that heat via this heat exchanger and return it back into my water system via these pipes. What this does is lowers my vent gas temperatures, which causes the system to condense, which removes sulfuric acid and ferric acid from carbon monoxide, removing 80% of the carbon emissions released into the atmosphere. This is my final stage domestic hot water heater. What this does is it increases the temperature of my incoming water from the solar. So whatever my delta rise is, or when my water temperature rises from the solar, this will then raise it only using the energy needed to get that temperature, desired temperature. We use this unit for bathing, cooking, cleaning, and dishwashing purposes for all household needs. This system will not operate during spring, summer, and partial fall seasons. So let's recap on all our systems. We have gray water recycling, which is going to save me 50% of my water consumption. We have our solar hot water and our radiant system and our cooling system, which saves me 75% of my fossil fuel usage and my electrical load in the summertime. And then, not to mention, my waste heat recovery from our vent gases with an 80% reduction in carbon emissions. And that was cost savings. But what I've really done is reduced my carbon footprint from this to this with these systems. And you can't put a price on that.